A 744B parameter model just ran on 25 GB of RAM. No GPU. The catch nobody put on screen. It takes 2.5 hours to answer one question. The project is called Colibri. One developer built it on their own 25 GB laptop. It runs GLM-5.2, a 744B mixture of experts model, by streaming most of its weights straight off an NVMe drive instead of loading them into RAM. It hit Hacker News on 2026-07-10 with 453 points. The top comment called it the hacker spirit. The engine itself is one C file. No Python, no BLAS, no GPU required. It compiles with GCC and OpenMP on x86-64 Linux with AVX2. macOS and Windows builds exist too, though Linux is the reference build. There's also an optional CUDA backend and Atari desktop shell. But the part that matters is that single C file. Colibri treats RAM, disk, and VRAM as one managed hierarchy, not an OS page cache trick. The dense parts, attention layers, and shared experts, about 17 B params, stay resident in RAM at NT4, roughly 9.9 GB. The other 370 GB of rooted experts live on disk. Each MOE layer has 256 routed experts, but the router only fires 8 of them per token, plus one shared expert. So just 9 experts get pulled off disk per token, not all 256. That's why a 744B model fits on a laptop at all. It wasn't shrunk, only the active slice per token gets read. This is genuine expert paging, not naive whole layer streaming, and it's the specific engineering trick that makes the headline number possible. Follow one token through the pipeline. The router picks the 9 experts it needs for this step. Colibri checks its RAM hot cache first, for experts that get reused often. On a miss, it reads straight from NVMe, batching each expert's 3 weight matrices into a single read, with async I/O overlapping the next expert's load against the current one's compute. While that's happening, it's already prefetching the next layer's likely experts, a claimed 71.6% accuracy, guessing one layer ahead. Then it computes and emits the token. Once it's built, wrap it in a one-line launch script. Point Colli model at wherever you downloaded the NT4 weights. Set the thread count to match your core count. 12 or more is what the project recommends. Then just call Colli chat. Here's the actual setup end-to-end. Grab the pre-built binary, or clone the repo and build from source with GCC and OpenMP. The NT4 weight download alone is about 370 GB, separate from the engine itself. First run is slow, while the expert cache is cold. Then it settles into whatever your disk can sustain. There's also a web command for a local dashboard, and a serve command for an OpenAI-compatible API, if you'd rather not live in the terminal. Here's every real number people have published. An i5 in 12v600K, no GPU, 0.8 TOX, a commenter's actual rig, a 13,700K, with an RTX 4070 Ti, 0.22, a Framework 13 laptop after cache tuning, 0.37, Apple's M5 Max, despite 14.2 GB of SSD throughput, 1.6, because the reads are scattered, not sequential. The best published number anywhere, a Ryzen 9950X 3D with 121 GB RAM and an RTX 5090, 1.23 tokens a second. That's the ceiling, not the floor. For contrast, 6 RTX 5090 seconds with the whole model resident in VRAM, a 50K plus server, hit 5.8 to 6.8 tokens decode with about 13 seconds to first token. That's not disk streaming anymore. That's a different machine entirely. Tom's Hardware calls 20 to 30 TOC the real-time conversational bar. A commenter on the competing video argues reasoning models need at least 30 TOC. Plain chat needs 15 to 20 before it stops feeling broken. One TOC isn't a slower chat. It's a different category of tool. Not even the best hardware from the chart you just saw gets anywhere near that pace. That same commenter tested it for real. A single-shot tower defense game in HTML came back as 8,128 tokens. At a generous 1 TOC, that's 2.5 hours for one prompt. GLM-5.2 is marketed as a coding and agentic model. Real agentic sessions run into tens of thousands of tokens across multiple turns. At this speed, that's not a coffee break. It's measured in days. The video that inspired this one framed Colibri as needing no GPU and just a short wait. Its own comments push back hard. The top comment, 52 likes, argues a small wrong stat gets copied channel to channel until nobody checks it. Another, 16 likes, calls it dishonest outright. Nobody can meaningfully run this on ordinary hardware, at best a fraction of a token per second. By the way, I post one of these daily. Subscribe if local AI interests you. A third commenter ran the real math, the 8,928 token example from before, and called out that framing directly once you follow the number to its conclusion. One commenter figured only 40B active meant light disk reads, then corrected themselves. The router still consults the full 744B pool to pick who's active, so per token reads stay heavy, roughly 11 GB per token. Another raised a real caveat the competitor video skipped. A 1M token context at Colibri's compressed KV cache size works out to around 182 GB before model weights are even counted. A third asked if this runs on 16 GB RAM. It doesn't. 25 GB is the hard floor, not a suggestion. Quality took a hit too. The README claims a perfect 32 out of 32 match against a full precision Oracle. An independent tester, GitHub issue Nubral82, only reproduced 30 out of 32. Run the speculative decoding heads at NNT4 instead of NNT8, and acceptance collapses to 0 to 4% per issue number 8. On diskware, the 370 GB expert store is read-only. Writes are mostly limited to the KV cache file, so the kill your SSD worry is overstated, though nobody's wear-tested this exact pattern long-term. The README's 372 GB NVMe recommended is the model alone. Add the OS, the download, and the KV cache file, and you need a dedicated terabyte drive in practice. A GPU doesn't help by default either. It only pays off once expert matrix multiplication, not disk I/O, is your bottleneck, and one consumer card holds only a small slice of the 370 GB pool. Zoom out to the model itself for a second. GLM-5.2 is 744B total, about 39B active per token, across 78 transformer layers, with a 1 million token context window, MIT licensed. The weights ship in many formats: G, G, UF from 1-bit through 16-bit, NVFP4, W4SATFP8, compatible with llama.cpp, VLLM, SGLang, Ollama, and LM Studio. Useful if you'd rather skip building the C engine. Its published benchmark scores, like 62.1 on SWE Bench Pro, are full precision numbers. They don't automatically transfer to Colibri's NT4 build, which scored 62.5%, mean normalized accuracy on its own small internal test. So here's the actual verdict. Colibri is real, clever engineering, and the 744B on 25G by headline is technically true, but runs is doing all the work in that sentence. At the RAM tier that makes the headline true, you're looking at hours per response, and it only gets borderline usable, 1 to 1.5 TOCS, once you add 128 GB of RAM and a fast NVMe. Where this is actually useful: overnight batch jobs, feasibility testing a mixture of experts' architecture before renting real GPU time, research into disk-based expert paging. It is not a ChatGPT replacement, and nobody serious is claiming it should be yet. Multiple independent write-ups land on the same line: a real proof of architecture, not a production server, no batching, no cluster-grade serving stack behind it. And once you add 128 GB of RAM, it's not any laptop anymore. It's a workstation you built specifically for this. If what you actually want is an interactive coding assistant, look at a smaller, dense model that fits entirely in VRAM instead. Colibri proves you can run a 744B model without a GPU cluster, and proves that's not the same as it being usable. If you want the real numbers before you trust a thumbnail, that's this channel. New video like this drops daily. Subscribe, and I'll see you in the next one.